Welcome back to the video series on how to make your own 5-axis do-it-yourself module for the Snapmaker Artisan. We will go ahead and we will try to make these parts in the next videos. So all the parts that I'm marking now are milled out of aluminium, all on the Artisan, and we will go ahead. I have split these objects into different sets. So one set will be this, another set will be this, and for the last ones probably they will be separate parts. They are a little bit more tricky because of these bigger holes that we have here. I will not go through the whole designing process of these parts. I will rather highlight some things I have done. I will quickly demonstrate it, but to have it more fluent I will just demonstrate it once and skip over these repetitive tasks for you. So let me demonstrate what I do in preparation of these parts. I delete this sketch real quick to show you. So what is very nice to use is this function offset. I like to use it, and I know that 7 works very well for the later cutout process. Another thing I want to show you is how I place the parts on the subplate. I will do this with the joint function. So I will switch on the origin so I can click on something here, go to the origin, then to my middle point of the subplate, and then I can just shift the parts how I want. I have already done this for you, so the whole setup will be able to be downloaded and you don't need to worry about placing this. But anyways, I wanted to show you how it's done. I have OLED all the parts that we produce, and based on this I knew where I can fix the parts and have one whole layout that can be used for all the setups that follow. The big one here and the pinholes here are also important to know in advance where they should be. I tried to set up the setups cleanly and name them so you can better navigate through them. What we will be starting with is the subplate preparation. So I will select the operations and show you what is done in the simulation. So just let me load up the simulation for you. The first task is with a 1.5mm tool to cut the holes needed for the M4 threads here. It will make its way downwards here, and afterwards we'll run a bore function just to clean the holes up. Once this is done, we will switch to the 4mm tool to make this big hole here in the middle. Let me fast forward here. So the big hole here in the middle, and it will also cut the holes for the 6mm pins. Once this is done, the next point, something interesting, will be the thread function. Let me show you here. Let me zoom in here. So the thread function will be with a special tool that I have chosen. It's a nice tool because it can cut M3, M4 and M5 with the same tool. This will be something we will be putting more focus on in this video. Lastly, we round it up by using our engraving tool and just deeper all these holes that we just created. I will be referencing myself to setup sections. I put the overview here so you always know which section I'm talking about, which section I want you to export as a G-code, or which section we are currently in, just so you know where we are. In the last videos we have talked a lot about how to create setups. However, if you're interested in how I did it for this video, just go ahead, click edit, and then you can check the depths. Maybe the stock dimensions is something that might come handy to check. You will also see that the setups have all been positioned in the machine correctly. Besides that, we also have tool parameters. For example, the 1.5mm tool is a new one we have not used yet. Just go ahead and check what is set here. You can also check the other depths if there's something you're interested in. But besides that, it's pretty basic stuff we have already gone through many times, and I will not bother to go over them again and again because it might become too repetitive for you. But what I will talk about is the thread function. The thread function is probably something new for you. Once we are there in the video, I will have a deeper look into it and show you how it's done. So let's jump to the machine. We start by placing our subplate with the pins in the cutting board, then just fix it with the outer screw holes, and once it's fixed, we will use our first tool. First tool in this case will be for setup 1 underline A, where we use a 1.5mm tool like you see here. Because I have just started the machine, I will execute a homing routine. Afterwards I use X0 and Y0 to go to my center point. If for whatever reason I have to find it again, because I have set it for something else, I can still reference to my values that I put on the controller. Afterwards it's touching the set, so we go down and check with our feeler gouges till we find our surface. Then we go 100mm up, and this will be our starting point. Now I want you to load up the G-code from setup 1 underline A and just start the G-code on the machine. It will start with the bucket function, will work its way downwards. I will fast forward here a little bit. You can see it cuts all the way downwards, switches to the next hole and continues the same procedure. Once we have pre-cut it, we will have afterwards a finishing cut, the bore function that you can see here, and then we have produced the holes and are ready to go to the next tool, which is the 4mm tool. Again, first we need to find the 0 position, so we go to our X0, Y0, Z0, go downwards, and again with the feeler gouges we try to find this surface. Once we have found it, we will go up 100mm in Z, and this will be our next starting point again. Now I want you to load up the setup 1 underline B G-code and start it. It will start with bucket function again, with the big one in the middle first. For the next section I will be quiet so you can hear the sound you should expect from the machine. So I allow myself to speak again. Once we have pre-cut it, we will also do a bore function that you can see here, just to finish up this hole, make it very smooth. Will make its way downwards again. Once this is done, it will switch to the next holes, the 6mm pin holes that are starting here, and afterwards this setup is also done. Because I have not changed the tool, I can use the same 0 point as before, and then I can load up the setup 1 underline C G-code. This setup is used to edge closer and closer to the desired diameter to have our pins fit tightly into these holes. Once this is done, I will use the hand deburrer to just remove the edges that you can see here. Just quickly remove the edges, that's enough. And then I try to fit in the pins. In this case they are not fitting quite well. So I repeat the process, always going up 0.0 or downwards minus, so 0.03, 0.04, 0.05, and at one point it will fit like you saw here. Let's do a quick cleanup with the vacuum cleaner, because now we will go ahead and make the threads. And let's jump first into Fusion again. I want to explain a little bit here. So let's go edit and into the geometry tab. Inside there we decide which thread we are making. So the M4 needs a 0.7 thread pitch, and I found out that the pitch diameter offset of 0.76 works well. For the bases, what I like to use is number of stepovers 2 and a 0.15 millimeter stepover, and I also check the repeat bases checkbox. Let's simulate this. So what will be happening when we start this G code is first the tool will go downwards and then it will spiral upwards. It will do this again but cut more to the side, and in the end it will do one more final cut for basically finishing up this thread here. Let me show you how I found the working parameters. What I did was I did a test with cutting threads on a part that I milled in half basically first, so later I can place the screws, and then I checked by zooming in basically if either the inner diameter or the outer diameter was too loose or tight. I followed the basic guideline Autodesk Fusion gave me on how to set these parameters, but the default values would not work. So what I needed to do is the inner diameter I needed to make a little bit wider, and the outer diameter a little bit wider also. I found working parameters for M3, M4, M5 already. Next one would be M6 and M8. I will find a place on the MiWiCNC website where I put these references, because I don't think there's so much value in trying to figure out your values yourself if I can provide a already working parameter set for you. Enough theory, let's go back to our actual part. We will mount our thread cutter. We will go to the 0 point again and go downwards. Note that we now have this big hole in the middle, but we still want to touch the set. What I do is I just go 20 millimeters forwards and then I reference on this spot here. Once I have found the surface, I will go 100 millimeter upwards. And don't forget also these 20 millimeters backwards again. This is our next starting point. Now I want you to load up the setup 1_D and start this. It starts on this hole, goes all the way down, and then it will cut the thread. Like we saw in the simulation before, it will make one pass, then another pass cutting more material. After this second run, it will go one more time with no additional offset to the side, just a recut of the same spiral it just did to finish up the thread. It's nearly done, and then it will continue with the next hole, leaving us with a nicely cut thread. The next and last part is the deburring part. We again go to our 0 point, go downwards. Again the 20 millimeters forward is needed, so we find a spot where we can touch off our surface. Once we have found it, we go 100 millimeters up, and again please don't forget the 20 millimeters backwards again. This is the next starting point. We will load up the last setup, the setup 1_E. And this I think you are already familiar with from the last episodes. It's just simply removing the edges of the geometries we just created. This is important. We don't want any edges standing upwards, as this can influence later our precision when we produce more parts on the subplate. I will just let this run out, and I will use this time to sincerely thank all of you that are part of this journey. It's a real pleasure to create this kind of content for you, and as always, I'm happy to hear from your feedback, what you like, what you don't like, what you think could be improved. It just helps me to refine the way I create content. Just remember, I'm still pretty new to this content creation. I'm still a very small channel, and every small little subscription, every small little comment, every small little like excites me a lot. So thank you for that. I will try to keep posts more frequently, but need to apologize in advance if I cannot always manage it. There's just other challenges in life that I also need to conquer. But thank you for watching, and I hope I see you in the next one. Bye.